This is part 3 of lecture 4 in Informatics 43. And now so in parts 1 and 2, we talked about what use cases are, why we use them, and how we can come up with use cases and design use cases. And now in this final part of this lecture, we will talk about use case diagrams. Here is an example of a use case diagram. What a use case diagram is simply a diagram, a graphical view that includes actors, use cases, and the interactions between them in a very abstract way. So it doesn't give you the details of all the use cases or the details of the actors, but it simply shows you what the use cases are. Those would lie within this system boundary, and the actors, who the actors are and which use cases they're involved in. And that's shown by these associations or lines drawn between the actors and the use cases. So in a use case diagram, we always have a system boundary. That's this box. In this case, it's the ATM system. And what the system boundary shows us is what lies inside the system you're developing and what lies outside the system you're developing. So the system is the system under development. So you can see the actors, those are external, remember, they're not part of the system, so they're outside the box. And then the use cases are part of the system. These are the goals that actors can accomplish with the system, so they lie within the system boundary. Each use case is represented by this oval with the name of the use case inside. And then, like I said before, actors are represented by stick figures, which actually isn't the best representation because remember that actors are not always humans. They can also be other software systems or hardware systems. But in any case, an actor is always represented by a stick figure. So you see here that we have two actors. We have an ATM user, that's a human. And we have a bank back-end system, which is a software system. And then we have three use cases for this ATM system: withdraw money, deposit money, and transfer money. And you can see that in this particular case, both of the actors are involved in all three of the use cases. So when an ATM user wants to withdraw money, well, that ATM system has to interact with the bank back-end system, because obviously it needs to find out how much money they have in their account, and then it has to subtract the amount from their account. And similarly with the other two use cases, those also both involve the user and the bank back-end system. And so each system that's under development typically has a main use case diagram like this one. Here's another example of a use case diagram. This is for an air travel system, a passenger service system. In this one, we have four actors. We have a human check-in representative. We have a human passenger. And then it's kind of unclear whether this could be a human or another system. And same with this one as well. So this could be like the baggage transportation system or a baggage transportation staff member. And same for this one as well. But you can see that we have use cases here. Check-in involves both the check-in representative and the passenger. So this is the case when you go to check in with an actual human working behind the counter at the airport. And so maybe both of them are involved in, both of them use the system together. Maybe this is actually more like when you go to a check-in kiosk and then there's a representative there to help you. And so both of you are interacting with the system. And then you have another type of check-in called automated check-in, and that's when the passenger is interacting with the system all by themselves. And then you have a couple of other use cases here that just involve the passenger. And this passenger service system also will allow actors to request a passenger list. And it shows here that these other outside actors, either humans or systems, are the ones that request a passenger list. Here's one more example of a use case diagram. This is an incident management one. So imagine like 911, what happens when, maybe this would be the system that a 911 dispatcher and their field officers would be using. So we have two actors, a field officer. Imagine this being a police officer out in the field driving around, and Then the dispatcher is another human. So these are both human actors in this case. The dispatcher is another human that's back in the police station or wherever that can allocate resources for some kind of emergency. So this would be the situation where, let's say that an officer is in some public place and all of a sudden maybe there's a gunman and so they need to request backup. So they use the system to report the emergency. The dispatcher is the one that receives that report, and the dispatcher opens an incident and can allocate resources like send backup to the field officer. And so they are both involved in these two use cases, but not in this open incident one. Only the dispatcher opens the incident. And remember that in all of these diagrams, it doesn't show you the whole story. So these diagrams would be used in conjunction with textual use case descriptions of each of these use cases, like we saw with the bioproduct use case. So each one of these, open incident, report emergency, and allocate resources, they would all be described in their own textual use case descriptions. And that's usually done using some kind of a template, whether it's very formal or very informal. Bringing it all together, what a system usually has in terms of use cases is one use case model per system. And what the use case model consists of is one or more use case diagrams and then textual descriptions of all the use cases in that diagram. So a lot of times you'll just have one use case diagram for a system, but sometimes you might split it up if it's especially large or if you want to look at it different ways. So the diagram and the textual descriptions together make a use case model for a system. Just like a requirements document, a use case model is not just for developers, but it has a variety of people that will be using it. And these are similar to the requirements audiences. You have everything from marketing personnel who want to use the use case model to understand what the system does so that they can market it, to, of course, software developers, technical writers that want to write manuals or documentation about it, project managers that want to know the extent of the system so they can plan how to develop that system, etc. So use cases are used as a unifying thread throughout development. They're used in the beginning, requirements phases, all the way till testing. Testers can use them to figure out what kinds of tests to write for the system to make sure the resulting system actually behaves like the use cases describe, all the way to people who are going to write the documents, software developers who are going to later evolve the program and modify it for future uses. And remember also that one of the main strengths of use cases are that they're easily understandable by diverse stakeholders, even those with non-technical backgrounds. So they're a really good tool to help everybody understand what the system is supposed to do. Remember that I said we'd be bringing back these fundamental principles in pretty much all software engineering topics that we talk about this quarter. And for use cases, in particular the ones that apply here, are first of all rigor and formality. You can see that creating use cases, identifying actors, doing the textual descriptions, coming up with the diagrams, these are all very detailed activities that require a lot of rigor, a lot of strictness in order to do them correctly and to do them thoroughly, rather than just start hacking away. Also, I've mentioned abstraction a few times in this lecture, where we want to frame our use cases in a manner that is not in too much detail, like showing exactly user interface details, but it has to be at the right level so that it communicates in a goal-oriented way the exchange of information between the actors and the system. And so we're abstracting away a lot of details, but that's okay because this is the purpose of use cases. And then in creating use cases, you are, in a sense, making the system modular because you're separating out the different goals into different parts. And that's a good application of separation of concerns. So to summarize Lecture 4, Parts 1, 2, and 3, remember that a use case is a textual description defining the interactions between an actor and a system to achieve the goal of that actor. and in particular the primary actor in that use case. We talked about different flows, the basic flow where everything goes as expected, the goal is accomplished, and it's the most common way to achieve that goal. Alternative flows where the goal is also achieved, but it's a less common way to do it. And then exception flows where the goal is not achieved for some reason. And so remember that every use case has a basic flow, and the alternative and exception flows sometimes apply to a use case, but not always. Every system has a use case model, which consists of one or more diagrams, along with textual descriptions of all the use cases in that diagram. In use cases, their main purposes are to serve as a unifying thread throughout development, from beginning to end, and to serve as a good communication tool and an understanding tool among stakeholders of all different types of backgrounds. All right, one more of the Your Turn activities. And now that we've talked about use case diagrams and you've already brainstormed some actors and some use cases, I would like you to put these all together in a use case diagram and again bring that on Thursday and we will go over those in class.